Lesson 7.4 is solving linear systems by multiplying first. Before we solve linear systems by adding or subtracting, and now we're going to have to multiply first. And this is why in some of your mixed review problems, we had to change equations that were in standard form by multiplying or dividing every single term by the same value. It didn't change the actual line, but it changed the numbers so that we could, in this case, use them to eliminate some of the variables. So here we go. In a system like the one below, neither variable can be eliminated by adding or subtracting. 6x plus 2x, 8x, 5y plus 3y, 8y. If I were to subtract, I'd get a 4x or I'd get a 2y. Nothing's going to work for us. So what we need to do is we need to choose one of these equations to multiply. And what I do is I always look to see if the coefficients in the terms are multiples of each other. And in this case, 6 is a multiple of 2. So I'm going to choose to multiply this entire bottom equation by 3. But really, instead of a 3, I'm going to use a negative 3 because I told you before I prefer using addition. And if I can get these terms to be the exact opposite, then I can go ahead and add them. So now I'm going to distribute the 3 throughout the entire equation, and that gives me a negative 6x minus 9y equals negative 15. Sometimes it helps if you write the other equation right underneath it, so I'll go ahead and do that. 6x plus 5y equals 19. I have exact opposite terms now, so I'm going to add. Negative 9y plus 5y is a negative 4y. Negative 15 plus 19 is positive 4. Divide by negative 4, and y is going to end up equaling negative 1. Now, just like before, I substitute this y value into the top equation, the bottom equation, or I can do it into my revised equation. I'm a creature of habit, and I generally just put it right in the top. So if I do that, I end up with 6x plus 5 times negative 1 equals 19. 6x minus 5 equals 19. 6x then, if I add the 5, is going to be 24. When I divide by the 6, x equals 4. So my ordered pair is 4, negative 1. Again, just keep remembering that if I were to graph this line and graph this line, they would intersect at the point 4, negative 1. So again, if you have terms, variable terms, where one coefficient is a multiple of the other, you only have to do the multiplication in one equation. That's not always going to be the case though. For example, here, 2 is not a multiple of 7, 7 is not a multiple of 2, 9 is not a multiple of 12, and 12 is not a multiple of 9. So what we want to do is we want to find the least common multiple either between the 2 and the 7 or the 9 and the 12. I'm going to shoot for the 2 and the 7 just because I think my numbers are going to be smaller if I do it that way. The least common multiple of 9 and 12 is actually 36, and I just prefer trying to multiply by smaller numbers. The least common multiple of 2 and 7 is 14. So if I multiply the 2x by a 7, I'll get 14x. And I'm going to multiply the 7x by a negative 2 so that I can get a negative 14x. So now I'm going to go ahead and distribute the 7. That ends up giving me a 14x minus 63y equals 7. And when I distribute the negative 2, I end up with a negative 14x plus 24y equals negative 46. And now I have two revised equations. Again, since I multiplied by a positive 7 and a negative 2, I created exact opposite terms, so I can go ahead and add. When I have the negative 63 and the positive 24, that gives me a negative 39y equals 7 minus 46 is negative 39. And my x terms did drop out. When I divide by the negative 39, I get a positive 1. Again, I usually put it in the top original equation, so that's what I'm going to do. But you could have chosen from any of the 4 equations. 2 times x minus 9 times 1 equals 1. So 2x minus 9 equals 1. Add the 9. 2x equals 10. Divide by 2, and x equals 5. So my ordered pair is 5, 1. In some cases, as in with the last problems, you're going to have to manipulate and put them in standard form first. So the top equation's good. I've got 4x plus 5y equals 35. This bottom equation, I want to subtract the 3x from both sides so that I can get it in standard form. So this is negative 3x plus 2y equals negative 9. Again, I do not have any terms where one coefficient is a multiple of the other, so I'm going to choose to find the least common multiple of either 4 and 3 or 5 and 2. I'm going to go ahead and do the 4 and the 3, and the least common multiple there is a 12. So if I multiply by 3 here, I'm going to end up with a positive 12x. I'll multiply by a positive 4 here so I can get a negative 12x. So I distribute the 3 and get 12x plus 15y equals 105, and distribute the 4, negative 12x plus 8y equals negative 36. Again, I've created exact opposites, so I will go ahead and add. This gives me a 23y equals 69. Divide by the 23, and I get 3 for the y. Put it back up in the top equation. 4x plus 5 times 3 equals 35. 4x plus 15 equals 35. Subtract the 15, and 4x equals 20. Divide by the 4, and x equals 5. So my solution is 5, 3. Last problem. A sports equipment store is having a sale on soccer balls. A soccer coach purchases 10 soccer balls and 2 soccer ball bags for $155. Another coach purchases 12 soccer balls and 3 soccer ball bags for $189. We want to find how much does each ball cost and how much does each bag cost. So I'm going to have the soccer balls be the x and the bags be the y. So x are the soccer balls and y are the bags. So I have 10x plus 2y equals, the total cost here was $155. And then the other one I have 12x plus 3y equals $189. Again, I do not have any numbers, terms, coefficients that are multiples of each other, but I've said it before, I like to use the smaller numbers. Least common multiple of 2 and 3 is 6, so I'm going to multiply this one by 3 and this one by negative 2, because again, I like to create opposites. This gives me a 30x plus 6y equals 465, and negative 24x minus 6y equals negative 378. I will go ahead and add. 30x plus negative 24x is 6x. 465 plus negative 378 is 87. Divide by 6, and there's a mistake somewhere.